Hello there, everybody. Welcome to Math with Mike. This is a solutions video. It's Tuesday, May 19th. It's day 28 of this whole COVID thing, and there's only 6 weeks left of school. So this is going to show you all the solutions for the 10 question quizzes for the next few weeks. So let's get right into it. The first question, these are questions with fractions. We always need to practice those. And so just as a quick reminder, when you're adding or subtracting fractions, this one in particular, let's use 7/8 plus 3/2. Well, that you need to put over a common denominator. Same thing if this was also subtraction. And when you put them over common denominator, that becomes 16. So this over 16 actually is double there, so it's double there, so that's 14 over 16 plus. Now how did we get to 16 from 2? Well, we times by 8, so 3 times 8 is 24. So we must have a common denominator to add or subtract, and then going across we add just the tops. So 14 and 24 is 38 over 16. The bottom stays the same. Same thing with subtraction. So that's addition, and secondly, addition and subtraction. And secondly, if we did multiplication or division, it's different. So that's our question. And so multiplication, you go straight across and just multiply. So it's way easier. So you actually get 7 times 3, which is 21, over 8 times 2, which is 16. That's our answer. Now let's say we wanted to divide. Well, that just takes an extra step. And if we divide by 3/2, then we have to flip it. And that's the same thing as writing 7/8 times 2/3. So that then just turns into something like this. You go across and you get 14 over 24 there. So that's the answer. So that is the first set of questions that you're going to see lots of. So let's move on to the more challenging things. Second question is quadratics. But this is just multiplication. So we need to practice these. You need to be really, really good at these kinds of things. So we're just going to keep practicing until you can't practice anymore. There's going to be 4 terms. We're going to do this rainbow or distributive property, whatever you want to call it. So x times x is x squared. X times minus 2 is minus 2x. 3 times x is plus 3x. And 3 times negative 2 is minus 6. Watch out for those minus signs. Now those two things come together, and we're left with x squared minus 2x plus 3x. Well, that just gives us 1x minus 6. So that distributive property should give you 4 terms, and those middle 2 should come down into 1. So that's the second question that you're going to see. The third question is scientific notation. Sci-note. What that is it's a fast way to write big numbers. You need to know this. So I gave you in the example the number 318000. If we want to write a comma, you can write it there. Scientific notation puts something in just a 1 point whatever times 10 to the something. So I'll give you the example here. So we write 318, but we write a decimal there. 3.18. You always have the lead number being a number between 1 and 10 with the point and then everything else. Then we multiply by 10 to the power. So how many powers? Well, you count 1, 2, 3, 4, 5. So this thing times 10 to the 5 gives you this. I counted the number of points that the decimal jumped. So you just count those points that, or the times the decimal jumps, and that is your times 10 to the power. This is an extremely useful way to write big numbers and needs to be understood by everybody. Now, the questions 4 and 5. So 4 and 5, those are going to be exponents. And exponents, the first ones are going to be just numbers. So in the first example, I give you 3 squared plus 2 squared all over 3 times 2. Well, what do? We need to know our exponent rules here. So just quickly, if you have 2 times 2, well, that's 2 squared, right? That's an exponent. But if you have 2 squared times 2 squared, you add those exponents, so you get 2 to the 4th power. And then if you have 2 squared to the squared, you multiply those and you still get 2 to the 4th. But if those numbers were different, then that would come out differently, obviously. So that's our quick powers. So the 3 to the squared times 2 squared, you can't bring those together. But there is this division. And so when something is underneath, you subtract. So we've got an implied 1s there, and 3 squared over 3. Well, that just leaves us with 3 to the 1 times 2 to the 1, or 6 overall. So again, when something is divided, let's say 2 to the 10 divide 2 to the 8, you subtract, and that would give you 2 to the 2. So you subtract those exponents. Those are the rules there. Then for the other part, we use the theory. And so you have to show the actual numbers, and now you have to show the theory, so you can't just get away with doing your calculator. So a squared times b squared all over a to the 1 times b to the 1. Well, you know that this is just subtract 1, this is subtract 1, and I'm left with a times b as my final answer. So hopefully that is helpful there. Now, on to the big second half. There is a lot to know about quadratics, and quadratics are pretty much all of grade 11. So, for the last sprint here, for the last 6 weeks, questions 6 to 10 are all, that wasn't very good, are all quadratics. So I'll show you what I mean. So I'm going to give you a quadratic. The example I give you is y equals 2x squared minus 3x plus 1. There is so much that you can do to that, and there's so much math that you can know with regards to that. But the first question I ask is up or down. What do I mean by that? Well, when a quadratic is drawn, it either goes like this, that's up, or it goes like this, that's down. So if I draw this, that's down. If I draw this, that's up. If I draw this, that's up. If I draw this, that's down. So, is it going up or down? The way you tell is up has a plus sign out front of the a term, and down has a minus sign out in front. So there is an implied plus sign here, so we know that goes up. If this was minus 2x squared, then it would go down. So you always look to this first term. This is the a x squared minus bx plus c. So just going over that as well, the format is always y equals a x squared plus bx plus c. Memorize this. This is a big time understanding. Sometimes you might be given a formula or a quadratic that's out of order, or maybe looks different. So like y equals x squared. Well, that means that b is 0 in this and c is 0 in this, but it's still a quadratic, and a is just 1. Let me give you another example. I could give this one up here, and a would be plus 2, right? B is minus 3, and C is plus 1. Those are A, B, and C, and we're going to need those for the quadratic equation and a few other things. So you always want to identify A, B, and C with no matter what you're doing. So the first things first is so question 7, where's the y-intercept? Now that means when x equals 0. Oh man, there's so much algebra here. What does that mean? Literally just set this to 0. So y equals plus 2 times 0. Well, wait, what's 0 times anything? It cancels out and becomes 0. Minus 3x times 0. Oh, cancels out. Doesn't matter. The only thing left now is plus 1. Basically, when you have to find the y-intercept is equal to c. Always. For every quadratic. Once you've set it up like this and you know c is going to be the y-intercept. So for question 7, you're always giving just the value of c. So that's pretty simple, right? All right, so for question 8, we leave the same one up here, 2x squared minus 3x plus 1. So that's the question that we're working from. What are the values of a, b, and c? This is the question 8. So a in this equals 2, b equals negative 3, watch those negatives, and c equals 1 or plus 1. You can write it either way. Just to do another quick example, if I said y equals negative 8x squared minus 6x plus 10, a here would be minus 8, b would be minus 6, and c would be plus 10. So that's just to give you another example. So if you write out a, b, and c, you get question 8 right. Now question 9, this is arguably the hardest part of this whole thing. Question 9 is find its x-intercepts. So the x-intercepts are actually found when you plug those values into the quadratic equation. What's the quadratic? It's negative x. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Memorize that. You're going to need it for all of math. So we've already been given a, b, and c, so let's plug it in. You've been doing this already a little bit. Negative b is negative 3 plus or minus the square root of b squared. Well, negative 3 squared minus 4 times 2 times c, which is 1, all over 2a, 2 times 2. Now, if you didn't already notice, I set this up to be kind of nice on the numbers, but they're not all going to be nice. So here, x equals 3, because the negative and a negative is a positive, plus or minus square root of, well, this is 9, negative 3 squared, negative 3 times negative 3 is 9, minus 8, or 4 times 2 times 1, which is 8, is just 1. So this is the square root of 1 over 4. So what does that mean? Well, that means that x equals either 3 plus square root of 1 is just 1 over 4, or x equals 3 minus 1 over 4. So what does that get? Well, that gets us at the bottom crammed in there, x equals 4 over 4, which is 1, or 3 minus 1, which is 2 over 4, which is 1 half. So for this, when you plug it in, x is 1 or 1 half. Now, when we're going to graph that, here's what that looks like. You want to hold on to those numbers, 1 and 1 half. When we graph it, we just need 3 points. X is the intercept, or is the line here, y is here. Now if x is 1, so let's say here, or 1 half, this quadratic passes through both of those points. And because it goes up, we know that it's going to look something like this. But where's this y-intercept that we saw? Well, it went through plus 1 here. So if I'm kind of thinking this is a U shape, what's the only thing that fits into here? Well, it's got to be something like that. It's got to go through all of those points and just dips below the line, comes back up, and goes up. And we throw some arrows on that. And that, ladies and gentlemen, and everybody in between, is the graph of this. You had the direction, it pointed up. You had the x-intercepts. You had the y-intercept, and that was enough to kind of put it together to create something that looked like a graph. So you're going to want the y-intercept, the x-intercepts, and the direction to end up graphing it. And that is going to get you through grade 11 math swimmingly. So I hope you enjoyed. Obviously, if you have questions, reach out, text me. I'm going to be posting this video, and I'll try to send it out every week or every day this week, in addition to the daily 10 questions. So thanks so much, folks, and looking forward to seeing your answers.